Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing the classic binary pattern, and today we will do the last question of this pattern, which is find peak element. So let's read the problem statement. A peak element is an element that is strictly greater than its neighbor. Means in the whole array we have to find the peak element, and the peak element is that element whose neighbors, means towards left side value and right side value, should be smaller to it. Okay, given a zero indexed integer array, find a peak element and return its index. So we have to find that element and we have to return that index. If the array contains multiple peaks, return the index of to any of the peak. Okay, so here in this question there can be multiple such peak elements, and in that case we are free to return any of those index. We have to write the logarithmic of n solution, definitely, because by linear search so we can find easily, but we will see the optimized code which will be done using binary search algorithm. Let's see the constraint. It says nums of length can go till 1000, so n will be 1000. So definitely linear search is also acceptable here because n is very small. But what if the n is very large? Then suppose 10 power 9. Then in that case the O of n solution will also give us TLE. So hence we have to go for the logarithmic. But here the problem itself says that we have to submit or write the algorithm that runs for log of n, means it is expecting us to submit the binary search algorithm. If you see the constraint of nums of I, it says it is the integer is already on their boundary levels, okay, the maximum value and the minimum value, and it also says that nums of I cannot be equal to nums of I plus 1 or for all valid of I, means there will not be any duplicate elements. That's what it means, right? Yes. So let's come here. Suppose for the example number 1, the peak element is 3 because it is greater than the left also and is greater than the right also. Definitely if we have to do this in by using one for loop, then we can start running our for loop from 0 index, correct? No, from first index, and we will check if it is greater than I minus 1 and I plus 1, then we can say yes, this is a peak element. But in this case 2 is not. 2 is greater than 1, yes, but 2 is not greater than 3, so hence 2 cannot be peak element. Similarly we will move our I here, and now we will see yes, 3 is greater than 2 and 3 is greater than 1 also. So hence 3 is the peak element, and then we can return that ith index. The time complexity will be O of n in that case, but the question expects us to submit the logarithmic of n solution. Let's see how can we do that. Definitely when it says logarithmic of n, binary search hits our mind, correct? Yes. But you will say binary search so we apply when the array is already sorted, but here it is not sorted, like it has not mentioned, correct? But if you see this clearly now, like if you see this here, like from the peak element, every element towards left is sorted in ascending order, correct? And towards right is sorted in descending order. Yes. Here also see what is the peak element? 5, correct? Towards the descending order, like towards the right it is in descending order, and towards the left it should be in ascending order, definitely. But why it is not? Because the question mentions that there can be multiple such peak elements, correct? But you saw na ki if there is only one peak element, left half and right half both will be sorted, but one, like left half will be in ascending order and right half will be in descending order if there is only one peak element. In this case 2 is also peak element. See, 2 is greater than the left one and right one also, and here 5 is greater than 3, and here if you see 6 is greater than 5 and 6 is greater than 4. So hence 6 is also a peak element and 2 is also a peak element. So if you see the indexes 0, 1, 2, 3, 4. Correct? Sorry, 4 for 5 and 5 for 6, correct? So you can return 1 index also and 5 index also in this case. Any of this is acceptable. But let's see how can we apply the binary search logic here. Okay, you know na, as of now, if we have found any mid value, any suppose 2, correct? And if it is a peak element, definitely it will be greater than mid plus 1, yes or no? Yes. But in this case it is not, so it is not a peak element. And if you see in the peak element, definitely this index is greater than mid plus 1, correct? Yes. Here also see 6 is greater than mid plus 1, yes. Here also, yes. So if that is the case, I can say keep that number 5 is greater than what? Greater than 6, yes. Then I can say that will be the peak element, correct? Yes or no? Yes. Or else we can find our answer in the left word for sure, but not in the right half. Have you understood this? Again, I'm repeating this. I have said ki if my nums of mid, okay, if this is greater than nums of mid plus 1, correct? If that is the case, what do you think? If mid element is greater than mid plus 1, can I say ki this can be our answer? I'm not saying only this. Why? Because, so let's take an example here, 1, 2, 7, correct? And let's say 5, let's say 4, let's say 3, okay? Okay, so let's take this example. If you see here, 7 is a peak element, yes, because 7 is greater than 2 also and 5 also, yes, yes. But suppose our mid element is 5. Let's assume for this, okay? So mid element is 5, and for this, so first if case will pass now, because yes, 5 is greater than its what? Mid plus 1, yes. So 5 is greater than mid plus 1, but does that mean it is a peak element? No. Why? Because for the peak element, the number should be greater than its left neighbor also and right neighbor also. Yes or no? Yes. So in this case, so it is not, but we are sure ki either 5 can be the mid element, or anything towards its left can be the mid element. Okay? Okay? So I am not saying it towards right you cannot find. You can, because the question itself says na, ki there can be multiple such peak elements, correct? Yes. Like in this case, it might happen ki after this you found 9 and you found 8. Okay. So definitely after 5 also we found 9 na, which is greater. Okay. So you might find. But I am looking for ki if I hit any number na, so that guarantees ki for sure there will be a peak element which lies towards the left side. Okay. And now to find that, we can eliminate the right half. Now if you are thinking ki what if in the left half we won't have anything, okay? So let's take some use cases, test cases according to that, okay? So let's see, we have 5, we have 6, okay, like this. So here the mid element will be 4. So if you see this mid element is greater than mid plus 1, yes. So it can be a peak element, because for the peak element we only have to check if this is greater than left or not, okay. But as of now we can consider it. So as per now, I am not saying it towards right you won't found. Definitely you will find, okay, if there is multiple peak elements, correct. But if there is no such multiple peak elements, definitely we will find towards the left side. Okay, okay. So what we will see now, we'll search in this half, and now the mid element will be 5, and definitely 5 is greater than 4. Yes. Again we will search in this half, again 6 is greater than 5. Yes. So now 6 can be the peak element. Now if you see ki 6 can also be a peak element because it is greater than its neighbor, and here left side there is no element present, so it can still be its neighbor. So in LeetCode it is expecting this to be as answer. But if you will see ki 9 is also a peak element because 9 is greater than 3 also and 8 also. So even if in this case you will return 9, it will still pass. Means I'm just trying to say ki you can write this logic such that ki you always want to find towards left side. That will also work. And if you will write the logic such that you want to find towards the left, that will also work. But in some cases, suppose there is no such element towards its right, I'm saying, okay, towards its right. So if you will stop in this case, suppose if you stop here, correct. So in this case for 3 cannot be the peak element, correct. So if you move towards right, you will not find any peak element, correct. So means I am saying you have to move towards left, because left side it is a peak element. But the only difference is ki suppose if you want to check towards left side now, you have to check the array of mid element should be greater than its towards its right element. Then only we can say ki either 4 can be the peak element or else whatever you found towards left side. But if you want to find towards the right side, you have to write ki if the array of mid element is greater than mid minus 1. No, then still you have to find towards left side. Suppose the array of mid here in this case 3 is greater than mid minus 1, yes. So now you can find the peak element towards the right side, saying 3 can also be the answer or anything towards right side. So hence you have to put your left at exactly mid and not mid plus 1, because still you don't know ki mid can be the answer also. So why to leave this? So hence put your left pointer at the same mid. Now if you got confused, two ways I have taught you. Key, you can find your peak elements towards left side or towards right side, because the question says anything you can return. So I am saying if you want to return everything, like all peak elements towards only left side first, then do this. If your nums of mid, like any mid element, is greater than mid plus 1. In this case it is not. But if you see here mid plus 1, here mid is greater than mid plus 1, yes. So I am saying this 4 can be a peak element or any number towards its what? Left. So in that case you have to put your right at mid minus 1, no, mid. So here you have to put right is equal to mid minus only mid. Why? Because I don't know ki mid can be the answer also or cannot be also. Okay. Now let's move it here. And now I'm saying ki if, now suppose you want to check everything towards its right first. So you can write ki if nums of mid is greater than what? Nums of mid minus 1. Yes. So if you want to move towards right side, you have to check towards left side first. So if here the mid element, correct? So is this greater than mid minus 1? No, it is not. No, it is not. So hence you have to go find the pivot element towards the left side. But if in this case, first case, if you will see here, yes, it is greater than what? It is greater than 1 only. Yes. So now you can say ki 2 can be the peak element or anything towards its right. So in that case, what you have to do? You have to put your left at mid. Yes. So you have to put here, you will put left is equal to mid. Correct? In the else case, you can go right is equal to what? Mid. Right is equal to mid minus 1. Yes. And in this case, else may you have to put, because in the if case you have put right at mid. So in else case you have to put left at mid plus 1, because in else case it directly says that mid is not our answer. So hence we will move our left is equal to mid plus 1. So in both the cases, wherever, with the whatever case you feel that mid can be the answer, put your point at exactly mid. Put your point at exactly mid. And in the else cases, you know that mid is not our answer, so leave that mid and leave that mid. Okay, so you can submit in either of these ways. So now what we will do, first we want a left pointer start from 0 and we want a right pointer that we will start from nums dot length minus 1, correct? Now I am saying run a while loop for while left is less than right, correct? Okay. Oh, sorry, my bad. Right. Okay. Now we have to calculate the mid element. The mid element we can calculate like left plus what? Right minus left divide by 2. Why we are doing this? To be on a safer side, because what if the left and right are so big? So you know the reason ki why don't we follow that left plus right divide by 2. Here it can work because the constraint is very small, but if the constraint is very large, then definitely we have to follow this, correct? Now what we will do, we have to check if our nums of, I am writing in such a way ki I want the peak element towards the left side. Okay, so nums of mid, if my nums of mid is greater than nums of mid plus 1, means it says ki the current mid can also be our answer, or else whatever towards left side. So in that case I will put my right at mid, correct? Yes. Or else what we will do? We will do left is equal to mid plus 1, correct? Yes. Now as you can see ki while loop is running until left and right hit equal operator. So after coming out of that, we know ki left and right both points to the same index, then only it stopped now. So we can return that index, either left or right. Whatever you will write here, it will get submitted for sure. So now we can run this code here and let's submit this code also. And you can see here it has passed with 100% and time complexity is logarithmic of n, because at every step we are eliminating the half part. So this is our C++ code with the same logic if you are from C++ background, and if you want I can write the right index instead of left also and we can run it, and you can definitely submit there on your own and you will find ki yes, both are giving the correct answer. Here you can see yes, they are giving the correct answer. Now here is your Python code if you are from Python backgrounds. So I have shared all language code. I hope this will be helpful even if you are from any of coding background. But now we'll do the condition for right side. Okay, let's try to find the peak element towards the right side. Okay, so definitely if here what we'll do, we will compare this with mid minus 1 now, because if this 6 is greater than mid minus 1, so I am saying we will find the peak element either at the same mid or anything towards its right. Okay, so can I write here if nums of mid is greater than mid minus 1? Yes, mid minus 1. If that is the case, okay, if that is the case, what I can say ki the answer can be at exactly mid or anything towards right. Means we have to shift towards right side here. We have to shift towards right side. So if you want to shift towards right side, definitely we have to move our left pointer from that left to what? Mid, correct? Yes, left is equal to mid. Yes. So that's what we will do here. Instead of right, we will do left is equal to mid. Okay, now come here. Suppose in this case, if that is not true case, suppose here we have 7. So definitely 6 is not greater than 7, correct? So when 6 is not greater than 7, definitely we have to find the peak element towards its left side. But as 6 is not the answer, so definitely we have to move our right pointer at mid, no, at mid minus 1. So here we will move our right at mid minus 1, okay, okay. Now, as you can see, the while loop will stop at left is equal to right. So we can return either left or right. Now let's run this. Okay. And when we will run this, now you will see a problem here. And that's what I wanted to talk about. Why we got this TLE when we wanted to search the peak element towards the right side. Let's see. Okay. So here, can I say that this is my mid element? Yes. Mid index, this is my right index, and this is my left index. Yes. So I am saying ki 6, like 6 is greater than 1, yes. So I want my peak element either 6 or towards right, anything, correct? So in that case, I will move my left pointer at exactly mid. So can I move? Yes. So let's move. Let's remove the mid now and let's make it left pointer, correct? Now we have to find the peak element in this, yes or no? Yes. So again, we'll find the mid element. So what will be the mid element? Tell me. Mid element will be 5. 5, yes. Now what we will do, is my 5 greater than mid minus 1? No, it is not true. Yes. So what we will do, if it is not true, what we will do? Come on, tell me. If it is not true, we will move our right pointer at where? At mid minus 1, yes. So in this case, right will come here, correct? And of course both are pointing to the same location, so it will come out of the loop and it will say yes, 6 is our answer. Yes, here to it will pass. But let's come here in this example. The mid element will be, come on, mid element will be this, yes. Left will be this and right will be this. Come on, tell me, is this mid greater than mid minus 1? Yes, it is. Yes, it is. So 2 can be my mid element, like peak element, or else anything towards its right side. So what we will do, we will move our left pointer, correct, and we will put here, left pointer we will put here, correct. Now we will try to search our new peak element here in this case. So left is here, right is here. What will be the mid element? Come on, 3, yes. So 3, mid element 3. Now let's see, is this mid element greater than mid minus 1? Yes or no? Greater than mid minus 1? Yes, yes. So again, now what we will do, we will put our left pointer at exactly mid. Yes. Now we have to find the mid element, like peak element here in the 3 to 1. Now what we'll do, the mid element will be 3 or 1. What? Exactly 3. Yes. So mid will point to this same index. Now we'll check, is this 3 greater than 2? It will say yes, it is greater than 2. So what we'll do, we will put our left index at the same mid, yes or no? Yes. Again the left is at here, right is at here. Again it will ask, is this mid? Because mid will also point to this same index where left is pointing to. It will again say yes. So again what we do, we put the left pointer exactly at mid. So again the left pointer will be at here. So we'll keep on doing this again and again and again. So how can we fix that? So what I am saying, you know now, when even length is there are 2 mid possible. Yes. What? 2 also and 3 also? Yes. So when we are focusing towards left side first and then right side, then you can think about mid element as the very first number we have found. Okay. Then it won't give you TLE. But when we are focusing towards the right side first now, and out of those 2 mid element now, I am saying just try to focus on the second one. If you'll try to focus there, then you won't get any such TLE. Why? Because here in this case, if instead of left, because left you are putting here only na at mid, correct? So what I am saying, how can you change your mid instead of left pointer? Definitely put your mid pointer or consider your mid pointer to be the second one. Like if the even length is there are 2 mid possible, correct? So take the second one. So if you will take the second one na, then definitely left will go at the same mid. And now left and right pointer will be same. But how can we take that second one as a mid? For that you just have to do left plus right minus left, you do na, divide by 2, what you do on to find the first mid, correct? If you do +1 here na, then you will get the second mid also. What you have to do, so instead of this left plus right minus left, you have to do +1 also, so that you will get the second mid, second half. And the simple code change if you will do na, you are done. As you can see, it has passed. So with the same approach, now we can submit this also, and you can see it has been submitted. So I actually wanted to talk about this point so that you will not feel pressured ki okay, you have to follow this rule only and not that. Okay, so whenever you are finding any binary search problem, trust me, genuine suggestion I'm giving you, try to write the code in both ways and see why only one way is working, why don't another direction is working. You have to find on your own, and then you will find, and then you will learn. Like how when we went towards right direction, we get to know ki okay, the mid index which we have to consider is the second one and not the first one, otherwise it will stuck in TLE, correct? So how you will fix it, when you will try doing something different from the educators also, correct? Because not every educator can teach you everything. One problem can have multiple solutions. So if we will discuss all multiple solutions in the same video, then the video will be very lengthy. So this is your task. If I'm teaching you any one way, try dry running or try debugging some another way and see if that another way is possible or not. If yes, do let me know in the comment section. If no, then find the reason why it is not. This is the exact correct path of learning DSA on your own. Now let's go on sheet and let's mark the next or last question from the very first pattern of binary search. And I hope you are also submitting with me. If yes, do let me know in the comment section, submitted or solved or understood, so that I'll get to know you guys are doing along with me. And if you are new to the channel, we are following the Rising Brain pattern wise sheet. You can get the link from the description, and if you guys want to connect with me on my Instagram, LinkedIn, Twitter, all the links will be in the description below. I hope this video was helpful. If it was, don't hesitate to share this channel to your friends. That's it. Let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family.